Assalamualaikum, hi class, welcome back. In this video, we're going to discuss about the hypothesis testing to test a claim concerning the mean difference for dependent samples. Now class, do you still remember what is the difference between independent and dependent samples? Please recall, okay, so it is the same concept that you learned in chapter 2. So the difference between independent and dependent samples that you learned in chapter 2 is the same as in chapter 3, okay? So I'm not going to brief on that already, so please recall what I explained to you in chapter 2. So if your claim is pertaining the mean difference for dependent samples, the test statistic formula is this. T-test equals to x bar d minus mu naught divided by SD divides square root n. Okay, so for the case of dependent samples here, we only, in applied statistic UMP, we only consider this test statistic formula, which is, this is the formula to use if you have the condition of sigma square unknown, sample size less than 30, which means that any assessment given to you for this subtopic, okay, hypothesis testing for dependent samples, the assessment will only be given for the case of sigma square unknown, sample size less than 30. All right, so even though in the formula book, if you open up your formula book right now, you can see that there are 3 formula under the category of hypothesis testing for mu d, but please bear in mind that for this course in this semester, we will only test you for this formula, okay, hypothesis testing for dependent samples. So I hope you all can still remember what is x bar d. It is the mean difference, and SD is the standard deviation difference. Okay, so this is the new learning point for you in this video. And another new learning point is that please take note on the notation used here. So if you can recall from my previous video for the independent samples hypothesis testing, we use mu1 minus mu2, am I right? mu1 minus mu2. But for dependent samples, we only use mu d. We use the notation mu d to represent the mean difference in a dependent samples. Alright, so you can only use this notation for hypothesis testing involving dependent samples. Alright, so now I think that's all that you need to learn from this video. Let us try an example, okay? A new gadget is installed to an air conditioner unit in a factory to minimize the number of bacteria floating in the air. The number of bacteria in the air before and after the installation of the new gadget is recorded, and the data are as follows, which means that they install this new gadget into the air conditioner and then they record the number of bacteria floating in the air. So it is supposed to minimize the number of bacteria, right? So they recorded the data before the installation and they recorded the data after the installation. So by looking at this data sets, it is before and after data, pre and post data. So that's how you know this is dependent samples. Okay, so that's the keyword here. That's the thing that give away this is a dependent samples. Okay, so that's the info, guys. That is the info that we get. What is the question? Is it wise for the factory management to install the new gadget? Is it wise? Okay. So by assuming the data is approximately normally distributed, test the hypothesis at 5% level of significance. So here alpha is 0.05. And yep, for this question, the variable is the number of bacteria floating in the air. Okay, so that is what being recorded. That is your variable. Now let's talk about the hypothesis. What is the hypothesis that we need to test here? Okay, what is the hypothesis that we need to test? Whether is it true or is it not true? Okay, so you need to decide whether is it wise or is it not wise for the factory to install the new gadget. So here let's think about this a little bit, okay? If the new gadget do minimize the number of bacteria, so it is wise lah, correct or not? So here you have 2 hypotheses. Your first hypothesis is saying that it is wise to install the new gadget. Okay, meaning that we say that the new gadget do minimize the number of bacteria. Or you can also hypothesize that it is not wise to install the new gadget because you think the new gadget do not minimize the number of bacteria. Alright, so you can choose any which claim, any which statement to be tested in your hypothesis testing. Okay, so for this case, for this video, I'm going to test the first statement. Okay, I'm going to choose the first statement as my claim. Okay, I will choose the first statement as my claim, which is to say that it is wise. Okay, meaning that I am claiming that the new gadget do minimize the number of bacteria floating in the air. So when I claim that the new, but this one needs to be tested. I only claim, but there is no proof. So now we're going to conduct a hypothesis testing to prove that my claim is correct. Okay, so now, what does it mean if the new gadget do minimize the number of bacteria? It means the number of bacteria before the installation should be more than the number of bacteria after the installation. Am I right? Kan, kalau dia minimize, after should be less than before. Minimize. So before is more than after. Same thing, right? Okay, so from here, I get the idea that the population mean of before data should be greater than the population mean of after data. Okay, then I move this to the left hand side and I get that mu b minus mu a is greater than 0. Yeah, and then since this is a dependent samples, I need to use the notation mu d. So I cannot leave my hypothesis statement as mu b minus mu a because this is dependent samples. I need to use this notation. Okay, mu d to represent mu b minus mu a. Okay, get it? Alright, so mu d greater than 0. So this is my claim. This is my claim class. So this is the first step. We formulate the hypothesis statement. So my claim is at H1. Okay, I am claiming that before is greater than after. So meaning that it is wise to install the new gadget. And my H null is mu d less than or equal to 0. Okay, so I need to write down here what does mu d represent. So mu d represent before and after. So next step class, we need to calculate the test statistic value. Okay, the test statistic value. So in order to use the formula that I showed you just now, we need to find sample mean difference, right? So we need to find the differences for the before and after data. Okay, so you pun buatlah. You construct a table or you may also not construct a table. I don't mind as long as you show me this data. Okay, this difference data. So I pun buat calculation before minus after. Okay, before minus after. Insert it into your calculator and get the sample mean difference and sample standard deviation difference. Substitute into the formula and you get 2.8281. So the hypothesized mean here is 0. Okay, because when we transfer mu a to the left hand side just now, so 0 is on the right hand side, right? So 0 becomes your hypothesized mean. Okay, so that's how you calculate the test statistic class. If you have any question at this point, do PM me immediately. Okay, that is the test statistic. Next, we're going to proceed to step 3, which is to establish the critical value and the rejection region. Since this is a right tail test, so the the rejection region will be on the right hand side only. Okay, acceptance region on the left hand side and the rejection region on the left hand side. And since your step 2 use t-test, that's why you will choose your critical value from the t-distribution table. Okay, so this is a correction. I'm sorry. Supposedly this is only t alpha. Okay, it doesn't need to divide it by 2 because this is a one-tail test. Okay, right tail test is a one-tail test. So your critical value here will be t alpha nu. T alpha nu. You don't need to divide it by 2. Okay, T alpha nu. So let's find it. Let's find the critical value, which alpha given is 0.05. That's the significance level given to you. So kita pun carilah. It is 0.056. Okay, which is 1.9432. So this is the critical value. T alpha nu. So nu here is n minus 1. Okay, 7 minus 1 is 6. So this is your critical value on the right hand side, the value that separates the acceptance and the rejection region. So now moving on to the fourth step, we need to make a decision, alright, whether to reject or not reject H null. So since the t-test calculated in step 2 is 2.8281, so this t-test is should be somewhere on the right hand side of your critical value. Okay, critical value is here. So 2.8 should be somewhere here. So therefore, this test statistic value falls in the rejection region. You're right. So that's why we will decide to reject H null, because the test statistic falls in the rejection region. And finally, we get to make the conclusion. So how do we make the conclusion, class? You need to look at your first step. Okay, you need to refer to your first step, which is your hypothesis statement. So here the decision is to reject H null. So your H null statement is not true. It is not being supported by our evidence here. So we have to reject H null and we will support H1. Okay, so what is the conclusion about the claim? So since claim is at the position of H1, since claim is at H1 and we support H1, therefore we also support claim. Alright, so this means that at 5% level of significance, there is sufficient evidence to support the claim that it is wise for the factory management to install the new gadget, because the evidence supported that the new gadget do minimize the number of bacteria after installing the new gadget. So this is the conclusion, class, right? That's it. Okay, we are repeating the same 5 steps in every video, but in this video, your new learning point is the new formula for the test statistics and the fact that you need to use mu-d notation in your hypothesis statement. Okay, you must use mu-d to represent the mean difference for dependent samples. That is all for this video, class. Please try on a few of these exercises if you do have extra time to do it, but if you don't, then it's okay. Just make sure that you understand this example and then continue to watch my next video on hypothesis testing for population proportion. Thank you. Bye.